Hi everyone, this is the review of chapter number 5, and in this chapter we will talk about the evaluation of roots of equations, how we can find out the roots. Like if you know this equation, you know that how you can find out the value of x at which this equation will become equal to 0, and you can find that there are two roots if it is scarce. So the same way, if we have the multi-level equations where we have the higher number of roots, more than 2, 3, 4 and 5, and we have some trigonometric equations and some other types of equation, and we have to find out the roots. So instead of going for the mathematical calculations, we just go for the numerical methods, and these numerical methods can provide us a very close estimate of these roots, and these estimates can be very close to the true values, and we can use it for our evaluations and for purposes. Okay, so these are the different methods that we will study. For example, in the chapter 5 of this book, we are going to study about the graphical and bracketing method. So the first part would be the graphical, and then in the bracketing method we will be studying two different types of methods. Number one, the bisection, and number two, the false position method. It is also known as regula falsi. Okay, so in these bracketing methods, whenever we have to use these methods, either these are the graphical or these are the bisection or false position method, we need 2 points, and these 2 points are known as upper bound x values and lower bound values. So what is upper bound value? Upper bound value is that value at which the function changes a sign after that value. So that value is known as upper bound value. For example, if you see 12, so the function is changing its sign after this value 12, and it depends on the interval. For example, in this graph, this interval is 4, so that is why we have one value of this interval 12 and the other value is 16. So the value just before when the function changes its sign is known as xl, and the value after the function changes its sign is known as upper bound. So this is the lower bound value and this is the upper bound. For example, in this case, we can call it xl, and this is xu, and this value at which the function changes its sign, this is actually the root of equation which is unknown, and that we have to find. Okay, so this is the x coordinate. For example, for this point, this is the x coordinate, and the y coordinate is actually the function value. We call it fxl if we use this 12, and it will be 16 if we use 16. It will be fxu. So if these 2 points are the function changes its sign, then the product of fxl and fxu should be less than 0. So it means that if this condition is satisfied, it means that the function is changing its sign. But for example, if this product is greater than 0, so it means that it is either both of these values are positive or both of these values are negative. In other words, the function is not changing its sign. So it's pretty easy. If this product is negative, it means the function is changing its sign, and this is the main condition for bracketing methods. So let's go for first the graphical methods. The graphical methods, it is the same concept. We need two values, and these two values are upper bound and lower bound, and we can draw the whole function. And once we draw the whole function, so this function will cross x-axis at some value. So this value is actually known as the root of equation. So what we do, we can use computer, and we can use Microsoft Excel, MATLAB, or any other Visual Basic program. So just plot the function, put different values of x, and where this function changes its sign or touches the x-axis, just read that value, and that value will be the root of equation. So you can estimate that value by adjusting the x-axis and the y-axis, and you can find that value. So this is how we use this method. This method is pretty simple. For example, if we go to the book, and here we have one example. In this example, it is the same example that we have solved in chapter 1, and this is the function the values are given here, and this is the equation. In this equation, once we put the values of mass and g, so the unknown in this equation is c, so we have to find out the root, uh, that is basically c. We can call it x as well, f, and this value is x and this value is x, and we can solve this question in Microsoft Excel. So first of all, we have to decide the interval. The interval, for example, this is the equation and this is the given equation, and we have to find out the root, or that value of c at which this equation will be 0. For example, this fc will be equal to 0, so that value will be actually the root of this equation. Okay, so let's quickly do that. We have some we plot on x. On one side we can plot x, and on the other side we can call like f of x. You can also call it c or f of c, whatever you like. Anyways, I call it c and this I call f of c. Okay, so let me maximize this one. Okay, so now we have to decide the interval. So this interval is based on your choice. You can select like 2, 4, 3, 6, whatever you like, but if you see in this equation, if you put 0 and if you start the values from 0, this is gonna be an infinite function. So it is not recommended to start this equation from 0, because you know that it is like an infinite value. So we can start it from 1. We can put interval of 1, 2, 3, 4. So let's use the interval 2, and here we can just write the equation for this equation. For example, this value is 667.8 divided by c multiplied by 1 minus 2.718 raised to the power minus 0.146843 multiplied by c, and whole this minus 40. So let me see if I did some mistake here. Yeah, here. So if I just correct it, it is 44.96645. So this is the value of c when it is 2, and then we can just increase this interval. We can increase the values 2 plus this, and we can go till that point where this function changes its sign. For example, let's see if I put these two values, or if I put more values here. So let's see where this function changes its sign. For example, no change in sign. Yeah, here this function has been changed. So if I just put value, so this is the indication that this function has changed its sign. So we can say the upper bound value of this function is 12 and the lower bound is 16. So it depends on these xl and xr values. Xu values actually depend on the interval. For example, if we see your book, so in the book they have the author has used an interval of 4, so you can use the same interval if you want here. For example, if I say it is 4 and this value is equal to this plus 4, so yeah, so we can just keep up to 20 and the remaining values we can remove. Okay, and then we can plot these values on scale on a graph. Insert. Okay, so and here we can plot these values. So this is the graph and this is the same graph which is shown here. The only difference is that it's more elongated, so I can adjust these axes. For example, if I just bring it back here and I can make it like the interval 4, so it's gonna be the same graph as you have seen over there, and this is the root of this equation. And you can just zoom in, and or you can just adjust this axis. For example, you can say the major crosses at 2 and the minor is 0.1. So in that way, if you just elongate back this axis, so you can just uh, adjust the axis and you can find out what is the root of this equation. So it seems somewhere 14.7, and that is going to be the root of this equation. You can further minimize this, and you can adjust the scale of the axis, and if you want more significant digits, you can also do that. The same way, for example, let's go for the next example. uh, yeah, the next example is example 5.2. Yeah, about this explanation, for example, there could be the different cases, and it depends on the function. For example, sometimes the function does not touches, so if the values remain positive and there's no change here, so it means either the function does not touch the x-axis or there are more than two roots. For example, if you see in this case, the both values are positive, so it means that there could be two roots or there could be no root. So if the function remains positive, it means either there are no roots or there are more than two roots. So in this case, the roots are more, but it depends on the interval. So keep in your mind, the interval plays a very vital role in all these calculations. And if the function changes the sign, for example, one is positive and the other is negative, so the either it has one root or it can have multiple roots. So this is I mean, just one graphical representation for different functions. It could be there could be more functions. Okay, this is the second example, and in this example, if you see here, on one side uh, you have f of x, which is actually this function, and the x should be changed from 0 to 5. Either you can use Excel or MATLAB. So let's do the same example here. For example, this is the x on one side and the f of x is on the other side, and x is, for example, it's 0 to 5, so the first value is 0, and the other value I just put it here, and it's sine 10x plus cos 3 multiplied by x. So, and then it's equal to this. I can now select the interval, maybe 0.1, this plus 0.1, and I can just control V here, and then I can calculate the values till 5. Okay, so we shall go to 55 or 56 here. Yeah, so here if I plot these values on x and y axis, so this is the function, and here if you see, this is the important point here, the function, it is not touching the x-axis, and the other behavior is pretty similar to the behavior here shown in the book, but it's not touching the here it seems that it is touching. For example, the book, the author has zoomed this part, and when it has zoomed, so you can see here it is touching, but in our example it's not touching. So the reason why it's not touching is interval, because maybe I have used a bigger interval and that point has been skipped.